Hoarding dice kind of goes hand in hand with tabletop gaming, and over the years I ended up with way more dice than I need or could possibly use. That said, my friend Saltiest Nick has recently been on a dice making bender, and he inspired me to figure out how to make my own dice from scratch. My plan is to design and 3D print some masters, then learn how to cast them in resin. In this video, I will go over the design process. It's very procedural, so almost anyone should be able to follow it, even if they have little or no 3D modeling experience. The tool I'm using is Blender, which you can download for free from blender.org. To begin with, let's clean up our workspace and get ourselves set up. We will not be needing the default light and camera, so we can just delete them. To make the workspace a bit easier on the eyes, let's go over to the viewport shading options. Select material capture mode and pick something a little less bright for our objects. While we're here, let's enable cavity and set the type to both. This makes the edges a lot clearer. I learned this setup from Artisans of Wool, and if you want to learn more about modeling for print in Blender, absolutely go check him out. Now that the display is a bit more comfortable to work with, let's start working on our dice. The first thing we need to do is find the center point of every face. To do this, we're going to select the cube and tab into edit mode. Click face selection mode, right click and select poke faces. This will add a point right in the middle of every face. And let's tab out to object mode again. What we're going to do next is add some placeholders to our cube. If you're only ever going to design one die, you can just go ahead and add the numbers directly, but if you need to change the font or anything in the future, then you'll have to reposition everything every time. Using placeholders takes a little longer, but it will save you work down the line. Let's add an empty. This is just a coordinate with no geometry attached to it. Any type will do, but I like arrow because it lets us see the orientation more easily. We want the empty to be in the center of the face, so we're going to enable snapping and switch it to vertex mode. We also want to make sure that the rotation and the line rotation to target are both enabled. Move the empty and it should snap to the closest face. The empty will control the orientation of the numbers, and I want the y-axis to be pointed towards the top of the die. Let's change the transform orientation to local so that we can rotate it around its own z-axis. Press R to rotate, Z to lock onto the z-axis, and 90 to rotate 90 degrees. Then press enter to confirm. We need to repeat this for every face, orienting the empty as needed. Once we're done, let's do a little housekeeping. Create a new collection for the empties and move them in there. Next, let's decide which empty goes with which number, and rename them. This is just so we don't have to click around to find out what goes where later. I just looked at a 6-sided die and followed the pattern. We're about ready to start adding the numbers, so now would be a good time to save this as a template for all the 6-sided dice you want to make. Okay, let's hide the cube and the empties for now and start creating the numbers. Add a text object, press tab to edit it, type 1 and tab out again. Under the text properties, let's extrude it to give it some thickness. You'll see that the extrusion grows in both directions from the origin. The operation we're going to use later to cut out the numbers will only use what's under the origin, and you could play around with the offset if you like, but I prefer to keep it simple and just make the extrusion twice the depth I want to have on the dice. Let's make that 0.2. By the way, I know that means 20 centimeters, but don't worry about it. We only need to worry about proportions, not actual measurements. The cube itself is 1 meter in size in Blender, and this will cut 10 centimeters into it. If we scale the cube down to 1 centimeter, the number would be 1 millimeter deep. The positioning is more important, so let's make sure it's centered both vertically and horizontally. This alignment is based on the font baseline, so it's not the perfect geometric center, but it's close enough for us. The default font is a bit bland, so let's pick a nice chunky one. We can also scale the object along the X and Y axis to make it larger. Enable the cube and switch on the X-ray mode to see how it will fit. Once we're happy with how it looks, let's name it 1 and duplicate it till we have 6 numbers. Rename the instances and edit the text in each one so that we have the numbers running from 1 to 6. They're all in a jumbled pile now, but we'll fix that next. Enable the cube again and move all the numbers to a new collection. Now we can pick each number and set its pair into the appropriate placeholder. The number will pop into place with the correct alignment. finish off the die, we're going to cut the numbers out of the cube. To do that, we'll need to convert each number into a mesh. Just select it, right-click and convert to mesh. Keep in mind that we won't be able to change stuff like the font after we do this, so make sure that you're happy with them before you do this. Once all your numbers are converted into meshes, go back to the cube and add a boolean modifier. Make sure the operation is difference. Change the operand type to collection and pick the collection your numbers are in. You won't see the difference right away because the numbers are still there, but if you hide the numbers collection, you can see your new die in all its glory. Let's export it for printing. Make sure the cube is selected. Go to the File menu and select Export and STL. You don't need to change much here, just make sure that Include Selection Only and Apply Modifiers are both selected. Hit Export STL and you'll get a file you can take to the slicer. Now that you know how to do this for a die 6, you can do this for any number of sides. It takes longer the more sides you have, obviously, but it's exactly the same process. I'll leave some notes on a free Blender add-on that you can use to generate more dice geometries in the description in case you need that. But now let's look at adding symbols. I want to replace the 1 on my die 6 with this shocked face. Let's hide the cube for the time being and add a plane. We'll need a lot of geometry to make this work, so let's tab into Edit mode, select Loop Cut, and set the number of cuts to 100. Click and press Return once to cut along one direction, then do the same across. Now our plane is divided into a nice mesh. We still need more points, so we're going to tab out of Edit mode and add a Subdivision Surface modifier. Next, we'll add a Displace modifier and create a new texture for it. Under Image, click Open to load the picture, and our plane should now be deformed. Dark areas from the picture will be moved way down. Let's tune it up. Go back to the modifiers and set the strength to 0.2, so it's about as deep as our numbers. We can also punch up the number of levels in Subdivision Surface to smooth it out. Apply both modifiers. The order is important. Apply the subdivision first, then the displacement. Now we can turn this into a solid. I'm using the 3D Print Toolbox, which is a free Blender extension. Again, details below. Click Make Manifold. This can take a while, but in the end you should see it close the gaps at the top of the stamp. Okay, let's replace the 1. Enable the cube again so that we can see what we're doing, and delete the 1 from the numbers collection. Then select the plane and set its parent to the placeholder that 1 was using. See? I told you they were useful. Select the cube and add another boolean modifier. This time leave the operand type as object, but change the solver to manifold, and set the object to plane. Again, this will take a while to process, but once it's done, you can hide the plane and see our symbol on the die. Okay, that's the die modeled. Now I'll have to see about getting this printed and go through the casting process, but that's a story for another time. In the meantime, if you want more tabletop crafts, check out the video right here. Bye!